The Eurolabs project offers transnational access to more than 40 European research infrastructures and brings together the three scientific communities of nuclear physics, detectors and accelerators for particle physics. The transnational access activities support small teams to carry out experiments and tests at these facilities. One of them is the EMClab facility at ITAINNOVA in Spain.
I'm Fernando Arteche, and I'm the Technology Coordinator of the Power Electronics and Electromagnetic Compatibility section at Instituto Tecnológico de Aragón in Zaragoza, Spain. The main goal of the EMC laboratory is to perform electromagnetic compatibility tests, both standard and non-standard, for any electrical and electronic equipment, such as power supplies, front-end electronics, and readout systems.
Within Eurolabs,
the laboratory is focused on the performance of tests to characterize electronic noise and grounding diagnosis in order to ensure the correct operation of complex systems such as particle accelerator and physics detectors. The users will have the access to two different EMC areas in the Institute. One area where we have a small semi-anechoic chamber 3 meter focused for component testing, and one Faraday cage focused for transient tests and radiofrequency conductive tests. The second part of the EMC laboratory is our big chamber, our 10 meter semi-anechoic chamber, which is mainly focused for mid-scale prototypes testing. The laboratory covers both emissions and immunity issues, including radiative characterization and conductive characterization, as well as transient tests. One of the peculiarities of our EMC laboratory is our 10 meter semi-anechoic chambers, which provides an electromagnetic clean room for mid-scale prototypes characterization. These chambers give us a perfect attenuation against electromagnetic waves from DC up to several gigahertz. Our team will help users to prepare the test setup, and we will operate the test facility. The laboratory covers conductive tests, both emissions and immunity, from DC up to 400 MHz, and radiative tests from a very low frequency up to 18 GHz in the case of emission and 6 GHz in the case of the immunity. This is possible due to our large amount of sets of current probes, antenna, radiofrequency amplifiers and generators. These facilities will allow to detector electronic designers to develop robust designs of detector electronics against noise, increasing the accuracy of physical measurements in a hostile electromagnetic environment.